You didn't think we were just going to be playing asteroids games forever, did you? This is Pi Noon. It's a more sophisticated example you can refer to in order to see how a variety of more advanced techniques are used. It's a simple multiplayer party game where you can throw pies at your friends. It's written in C++ and supports up to 4 players using a multi-screen mode with Android TV. In this section, I'll introduce topics and technologies that help you create a great gaming experience, as well as some that take advantage of the unique capabilities of Android. We won't go into great depth with each of these, but you will get an idea of what the different components have to offer. And when you're ready, you can explore further on your own by following the links in the instructor notes. First up, we have Google Play Game Services. You can think of Google Play Services as a toolbox which is tightly integrated with Android. It helps you with common tasks in game development. These include storing and synchronizing game data on the cloud, as well as sending invitations and auto-matching players. Also included are tools to help you build real-time and turn-based multiplayer gaming experiences. It also helps you build achievements and quests into your game, which are great ways to hook players. You can also collect analytics data to help you understand how players interact with your game. All you have to do is create an account on the Play Developer Console, and this works a lot like the Cast Developer Console we covered earlier. All of these features are free of charge, aside from a small one-time fee to verify your account. After that, you can access all of these games features via a Google API client, just like when you use any other feature in Google Play Services. And don't forget to add this scope games when you create your API client object. That's a common mistake that developers do all the time. Next up are Nearby Connections. The Nearby Connections API lets you discover other devices on the local network and exchange messages with them in real time. This lets you do 2 great things. First, you can allow one player to set up a multiplayer game on the local network and then have other players join in. Or, much cooler in my opinion, one player can set up a game on a shared device like an Android TV. Then, other players can join in using their mobile device as a display controller combination. Individual players see a customized display on their mobile device as well as a shared display on the main screen. This is a very unique and extremely catchy capability, and it makes your game super easy to use and fun to interact with. Inside the instructor notes, you'll find a video demonstrating exactly how this works and doc you can follow to build this into your game. In Android 5.0 Lollipop or higher, multiple networks are supported. This means that there can be more than one connected network on an Android TV device at one time, for instance, both Ethernet and Wi-Fi. You can check for this case using the Connectivity Manager, and if so, you can actually select the type of network you'd like to use in your game. Although there's usually not a tremendous difference, some developers prefer Ethernet for the slightly lower latency. Next up, we have WebP. WebP is an open-sourced image format developed by Google. It's more space-efficient than JPEG or PNG, without a noticeable loss in quality. You can use this to compress your textures and reduce the size of your final game package. WebP supports transparency and lossless compression, as well as lossy compression if you need even smaller file sizes. As a default, this is supported by Android TV, so you don't need to add any external libraries to encode and decode WebP images. There are also open-source libraries for other platforms. And speaking of Pi Noon in C++, you should be aware of the Android NDK, or Native Development Toolkit. This toolset allows you to implement parts of your app using native code. A really important note here, the vast majority of apps will not benefit from this approach, and you should do this only if you have a very good and very specific reason. The best reason I can think of is if you have a large pre-existing code base you'd like to reuse, like in the case of Pi Noon. Generally, the performance trade-offs of using C++, if any, are not worth the complexity cost. Now on Android TV, NDK almost always works without any problems at all. However, I'd strongly recommend you test your code on a real device, not an emulator.